So hey, hi guys, welcome to the channel. Yeah, today we'll study about data warehousing with Apache Hive. Okay, you can say we'll study about Hive, basically how it's work. Okay, its internal structure and everything. Right. So let's get started. Yeah. So you can see the name itself. It is data warehousing using Apache Hive. What is data warehousing? First, you have to know what do you mean by data warehousing. Okay, so a warehouse is like a huge library, okay, where data is stored in a well organized way. Yeah, simple term. What do you mean by warehouse? A huge library where you can store in a well organized way. It is designed for querying and analyzing large volumes of data. Simple as it is. So what is data warehousing? It is something where you can store a large amount of data in an organized way. Why in an organized way? So that we can retrieve the data in a faster way. Okay. Next, why why hybrid data warehousing? So you got to know what is data warehousing. Now, why we are using Hive in data set in data warehousing. Okay. So basically, Hive is built on top of Hadoop. We have studied Hadoop in our previous lecture, right? How it is distributing the data among different machines. Okay, so Hive is built over that Hadoop. Okay, a framework that is handle vast amount of data by distributing the storage and processing across many computes. Okay, so basically Hadoop is a system which distribute the data and load in different compute system. Okay, by distributing this, it achieve to uh, to compute large amount of data. Okay. So Apache Hive act as a bridge between the world of SQL and the world of big data. Okay, now let me make the things clear, very clear. First, what do you mean by Hadoop? What do you mean by Hive? Hadoop, it is a system. Okay, it helps to distribute the big data into different compute systems. Okay, into different node you can say. And Hive, it is a what is- it is a bridge between Hadoop and SQL, the world of SQL, so that we can any query will read the SQL query, it will retrieve the data from the Hive. Okay, now I guess it makes sense. What do you mean by Hive and what do you mean by Hadoop? Okay, Hive is a bridge between the world of SQL and the world of big data. As simple as it is. Okay, next we'll understand the Hive architecture. This is important. Okay, you can see the diagram. Yeah, we'll go each by each what exactly is doing. So when you write a SQL query, okay, let's suppose in your database there is a table employee, and you write in your SQL query editor, you write select star from employee. Okay, so when you write this, how the scenario behind how the Hive is managed to retrieve the data to you, what are the process Hive is follow, we'll see here. Okay, so you can see from this, you can see it start from the CLI. Okay, when you write the SQL query, first it comes to the CLI, or you can say B line. Okay, this is our entry point. Okay. So in the old school command line interface of Hive, it's straightforward, allow you to run the Hive query. Okay. So as I mentioned, in the entry we have CLI or B line. In the old school we are using Hive CLI. It is directly allow you to fetch the SQL queries. Okay. But Beeline, this is the modern tool for connecting with Hive. This is the modern tool. Why? It's connect via JDBC connection. JDBC is the most secure, flexible connection. So now what we are using? We are using Beeline for okay for entering into the machines. I can say. Okay. The first step is CLI or Beeline. Can replace CLI into Beeline. Okay. Next, you can see this is a driver. Okay. Inside driver, you can see four component parser, planner, execution, optimizer. We'll go each by each and see what these things are doing. Okay. So driver the query processing hub. Okay. Once you execute your query via CLI or Beeline, the SQL payload comes into driver. The following operation take place with Hive driver. Okay. So the once this CLI or Beeline execute, it will okay execute. Then driver comes into play. And what does happen in the driver? This is the process. Okay. While receive the SQL query. So as I mentioned, you write select staff from employee. By the time it will goes to Beeline. Beeline check. Beeline check basically Beeline. Um, so it's typically used to production environment because it support remote access. Okay. So Beeline model tool technology that connect to Hive via JDBC. So once it's connect, the next step is parsing your Hive QL. Okay, it will parse the query that you have right. Then it will make optimization. So is there any scope of optimization? It will perform that. Okay. Then plan execution. It will plan the execution. So we have basically two planning. One is logical plan and there is physical plan. Okay. In logical plan, the driver creates a logical path. This is a high level blueprint that outlines what needs to be done to execute your query. It is like having a receipt that tells you the steps you need to follow, but not the specific how to understand. This is a logical thing. It will give you all the logical information. Okay, these things we have to do. This is the list we have to plan. Okay. Next is physical plan. Physical plan. The logical plan is then translated into physical plan. So whatever plan you have decided in the logical plan, you have make a receipt that these are the thing we have to need, you have to do in physical plan. You are actually doing that. This where the magic happens. The physical plan breaks down the steps into actual jobs, like map reduce, stage or sparks jobs. It will break down the jobs, actual jobs. Okay. That will process the data. It specifies exactly how to handle the data, such as scanning, filtering, and joining. Correct, clear, the plan execution. Next, we'll see the query optimization. Okay. So before running the query, the driver optimize the plan. Okay. This is about making your query run faster and more efficiently by refining the steps such as pushing filter down to reduce the amount of data processed or reordering the join to minimize the data shuffling. Correct? You can see the next step here. It is optimizer. After planning, it is optimizer. So what does optimizer do? You'll study, right? You come to know. Okay, let me repeat once. What is optimization? What is optimizer do here? So before running the query, the driver optimize the plan. This is about making your query run faster and more efficiently by defining the steps such as pushing filters down to reduce the amount of data processed or reordering join to minimize the data shuffling. Clear what is optimizer do? Now execution. Okay. So finally the optimized physical plan is execute. The- See the optimizer give you the optimized plan, right? Okay. So once you receive the optimized physical plan, this involves running the specific job to reduce the data. Once the process is complete, the results are fetched and sent back to you. Correct? So optimizer decide which optimization technique should I use, MapReduce, Spark or Tej or any optimization technique so that we'll get the most optimized process data. Okay, so once the processing is complete, the results are fetched and sent back to you. So once the processing is complete, the result sent back to you. Next is HDFS, where your data lives. Next is HDFS, where our data is lies. HDFS stands for Hadoop Distributed File System, and it's where Hive stores the actual data for your tables. It's designed to handle large volumes of data across many machines, providing fault tolerance and high speed access. Imagine HDFS as a giant distributed hard drive where your data is safely stored and easily accessible. You got the point? What where your data is lives? It's lives in your HDFS, Hadoop Distributed File System, and it is where Hive stores the actual data for your table. Okay, this is designed to handle large volumes of data. Next is Metastore, the Meta Hub. Next is this. You can see this rightmost block, Metastore. Okay, so metadata repository and database SQL is the two things how it is how metadata store the data. So in metadata repository, the Hive Metastore is central component that stores metadata about your Hive table, database, partitioning, and other objects. This metadata is crucial because it tells Hive about the structure and organization of your data. Okay, so metadata repository is most important. What is this doing? The Hive Metastore is a central component that store metadata about your Hive table, database, partitions, and other objects. This metadata is crucial because it tells Hive about the structure and organization of your data. That's why it's very important. Okay. Next is database storage. So the Meta store uses a relational database like MySQL, PostgreSQL, or Derby to keep this metadata. This ensures that the metadata is durable and consistent, and it can be managed independently of the actual data stored in the HDFS. Now good to know what is the meta store, that metadata hub. Now you'll get to know the flow of querying execution in Hive. Okay, this is something bit important also. So let's see. So, the flow of it, the flow of query execution in Hive. So when you run a query in Hive, several steps are involved in processing and executing it. Okay, here's a detailed breakdown of the entire process. First, submit the so you start by writing your submitting a HiveQL query using a tool like Hive CLI or Beeline. This is your entry point in the Hive ecosystem. You already mentioned it. The first step. Next, querying submission to driver. Next step, we have seen this, right? How the driver works there. The four steps in the driver: parsing, optimization, execution. Hope you remember. So next is parsing the query. Yeah. What does it here happens? Action: the driver begins by parsing the query. Purpose: it check the syntax to ensure the query is correctly. Okay. A semantic analysis. Next step is semantic analysis. Okay. The AST then subject to semantic analysis purpose. The step involve validating the query against the schema and metadata in the Hive metastores. Okay. It ensures that the table, columns, and the other element referred in the query actually exist and are correctly used. So this is something it will check your syntax. Not syntax exactly, it will validate your data that is actually present or not. Right? Semantic analysis. Next is logic plan generation. Fifth number, logic plan generation. What does it do? Based on the result of semantic analysis, the driver generates a logical plan. Okay, so based on the semantic analysis. When I say semantic analysis means involve validating and querying against the schema and metadata in the Hive metastore. Okay, kind of double check, double ensure that whatever the data is actually querying is present or not. Okay, this is semantic analysis. Logical plan generation, what is it done? The logical plan outlines the steps needed to execute the query, but does not specify how this step will be implemented. It's like a high level blueprint or recipe. Okay, you have to remember. Point number six, physical plan generation. As you have expected, first it is a logical plan, then second is physical plan. So this physical plan specify how the local steps will be executed. Okay, it includes details about the specific MapReduce, there's a Spark job that will process the data. Okay, so physical and logical generation clear. This logical plan outline the steps needed to execute the query but does not specify how this step will be implemented. It's like a high level blueprint or recipe. Got it? Next is 7, uh, 6, physical uh, generation. Okay. 6th one. What is done? The physical plan specify how the logical step will be executed, include detail about the specific MapReduce stage or Spark job that will proceed with the data. Got it? Physical plan generation. Next is query optimization. These all are step. The physical plan undergoes optimization. Okay, the purpose, the goal is to improve the efficiency of query execution. This can involves techniques like predicting pushdown, job recording, and column pruning. So predictive pushdown, moving filter closer to the data source to reduce the amount of data processed. Okay, next join recording, changes in the order of join to minimize data shuffling. Column pruning, remove unnecessary column from the processing pipeline. So these are the three steps in query optimization are essential. Okay. What are the predicted push down, join recording, and column pruning? Okay. Next is execution. The execution. So purpose, this involves running the specific MapReduce, Thais or Spark job to process the data according to the physical plan. Okay. Just reading it out once more. Execution, this involves running the specific MapReduce, Thais or Spark jobs to process the data according to the physical plan. Got it? Next. Once the execution is complete, the result are fetched. Purpose. The result of the query are collect and replace to the and prepare to the send back to the user. Yep. Next is return result to user. So that will be random. Nine. This one is number 9 is fetch fetch result. The result of the query is are collecting and prepared to be sent back to the user. Now, number 10, the final is return result of users. Return results of users. Okay. So the final step is to return the query result to you through the Hive CLI or VLAN interface. Simple as it is to return, we can return from the particular given point, how we will mention. A visual summary. That's it for Hive architecture. I think the tomorrow's class, I will teach you about another topic. I can say the store efficiently in big data. Okay, so thank you. Bye bye.